Here's another example. Find the dimensions of an open box with a square base and surface area of 192 that has a maximum volume. So it's an open box, the base is a square, and the surface area is fixed at 192. So the first step is to sketch the situation. And what we have is a box with a square base. So something like that. We don't know what the height is, but we'll soon find out. So okay, so this is my box. Now it has a square base. Now I don't know what the length is, so we can say let its length let its length be equal to x, which means its width will also be equal to x, and let its height be equal to another value which you don't know, so we'll just use a variable to represent that. So that is x, x, and that's y. Okay? Now, and the idea of using algebra here is important because that will help us to write a model that will model this situation and work with that model. Anyway, step 2, we need to write an equation for the quantity we want to optimize. So step 2, write an equation for the quantity we want to optimize. So here, what we want to optimize is volume. So we need to write an equation for the volume of this box, which is open, right? Remember, it's open. Need to use a different color for that. So the box is open. So the volume will just be length times width times height. So that will be x squared multiplied by y. All right, let's carry on. Step 3, now we need to rewrite because this equation is in terms of 3 variables. Now we need to rewrite the equation that we developed in step 2 to be in terms of one single variable. Okay, so step 3, you need to rewrite the equation in step 2 to be in terms of one single variable. Okay, but how do we do that? Now we know from the question the fact that the surface area of this box is fixed at 192. But how do we find the surface area of an open box? It will be the area of each of these faces. Okay, so the surface area of this box will be given by the area of each of the faces. Now the area of the base is x squared. Now the area of the other four faces will be x multiplied by y. So which means that will be 4xy. And we can make y the subject of the formula. By the way, the surface area is equal to 192. It's fixed 192. Now, if we want to make y the subject of the formula here, y will be equal to 192 minus x squared over 4x. Okay, so which means we can take this value of y and plug it here in place of y. That way we'll end up with an equation. We're writing that equation, and we want that equation to have one single variable. Okay, so what I mean by that is this: we need to plug in what we have for y into that equation, which means we shall end up with v. Okay, so this will be v will be equal to x squared multiplied by 192 minus x squared over 4x. Okay, and then we have to simplify that. So this will be equal to and by the way, this x can cancel, x and x will cancel, so we'll have x there. So which means my numerator will be 192x. So that will be 192x minus x cubed over 4, which can be written as 192 divided by 4. So anyway, that's 192x over 4 minus x cubed over 4, which is 48x minus x cubed over 4. So that is now our new equation in terms of one single variable. Okay, so we have that. What will be the next step? The next step will be to take the derivative and find the critical points. So we need to take the derivative of the volume. So step that will be step 4. Take the derivative and find the critical points. So we need to find the derivative of this function. The equation v is equals to 48x minus x cubed over 4. The derivative for that will be dv. So dv over dx, and that will be equal to 48 minus 3x squared over 4. Okay, so we have the derivative. We know that critical points occur where the derivative is equals to 0. So we are going to use that idea to be able to find the critical points. So we know that critical points occur where dv over dx is equals to 0. So we just need to equate this equal to 0 and solve for it. So which means here we'll have 48 minus 3x squared over 4 is equals to 0. And what we'll end up with is 3x squared over 4 is equals to 48, and that will lead us to x squared is equal to 4 multiplied by 48 divided by 3, that will be 64. So either x is equals to 8 or x is equals to negative 8. Now remember, x here represents the length, so x cannot be equal to negative 8 because length cannot be equal, length cannot be a negative, so you cannot have negative length. Okay, so x represents length. Okay, so x is 8. That's our critical point. So what do we do next? We need to justify that the critical point that we've calculated represents the maximum. So that will be step 5. So step 5, we need to justify that the critical point represents a maximum point. And we have to use the second derivative test. We don't have to, but we can use the second derivative test. Which means we need to find the derivative of second derivative of this function. Now the first derivative is given here, so we just need to find the derivative of the first derivative to find the second derivative. So which means the second derivative will be equal to negative 6x over 4, which can be simplified as negative 3 over 2x. Now at x is equals to 8, because that's our critical point, the second derivative will be equal to, you just plug in, so negative 3 over 2 multiplied by 8, which will be equal to negative 12. So we can see here that the second derivative is negative. Now since the second derivative is less than 0, then a maximum point occurs when x is equals to 8. So we can say that since the second derivative at this point is less than 0, then a maximum point occurs when x is equals to 8. Okay, so a maximum point occurs at this point. So we have confirmed that, we've justified. So what will be the final step? The final step is finishing off the question. And what the question is asking us to do at the top, the question is asking us to find the dimensions of the box. So we are going to find the dimensions of the box. So that will be our last step, which is step 6. So step 6, find the dimensions of the box. So we can find the dimensions of this box. We know that x represents the length and the width, so we can say the length and width is 8 centimeters. The height of this box which is represented by y, will be, now remember, we had we came up with an equation representing y while we were solving this question. Okay, here. So y is 192 minus x squared over 4x. So you're just going to plug in 8 to find what the value of y will be. So here, the value of y will be 192 minus x squared over 4x, which is 192 minus 8 squared over 4 multiplied by 8, which is 4 centimeters.